Hey everyone, welcome back. By default, Kubernetes Network Policies let you control pod-to-pod communication inside your cluster. But what happens when an external user needs to reach your application, or when your backend application needs to call an external service like a public API? In this video, we are covering two essential network policy patterns. One is allowing external ingress access, means how to open your application securely to public users, and allowing and controlling external egress traffic. That means how to let your pods make outbound calls to external destinations without exposing your cluster. For this tutorial and lab environment, we are exposing our pods using NodePort service for simplicity. Keep in mind that NodePort is used strictly for development and testing purposes. In a production setup, you should always route external traffic through a proper Ingress Controller or load balancer. Let's create a NodePort service to expose our web application to external users. And here is how the manifest breaks down. We set the kind service to define a Kubernetes service and name it as frontend-svc. We deploy it in the frontend namespace where our target web app pod lives. The selector under the specs section points to run web app. This tells the service to route traffic to any pod in the frontend namespace carrying that label. Under the ports section, the protocol is set to TCP for standard web traffic. Port set to 80, exposing the internal service port within the cluster. And target port set to 80, matching the port inside the container where the Nginx listens. Node port set to 30,080 or any available port in the standard range, which is like 30,000 to 32,767, to allow external access to the host's node IP address. Finally, we set the type as NodePort, so external clients can reach the service from outside the cluster. Let's get this manifest deployed to our cluster. Once it's deployed, let's access the NodePort service by clicking on the link here to check if the web app is accessible. The connection failed as expected. Why? Because a default deny network policy is currently blocking the path. To allow traffic through, we need to adjust the frontend to middleware allow egress and ingress policy located in our frontend namespace. We need to amend another ingress rule to our existing policy to allow this traffic. This rule will allow incoming TCP traffic on port 80 from any IP address. Let's edit our existing policy and then add this rule and save the changes. We should be able to access our web app pod by clicking on this link here. And it seems the connection is successful as our web app pod in the frontend namespace is displaying the text frontend. So in this exercise, we have learned about adding new ingress rule to our existing network policy using ipBlock, and even restricted the protocol and ports to make our web app pod accessible to the public. Next, we'll simulate a use case, let's say to allow an external service that periodically takes backup of our database. This could be done in multiple ways. However, the focus here is about tweaking the existing network policy to enable connectivity to the external service so that it could perform the backup. As a prerequisite, you should already know the IP address of the external system that you want to whitelist. In this demo, we'll be simulating this use case by making use of a weather forecast website https wttr.in, and try the connectivity from the MySQL pod in the backend namespace. Reaching the website from the MySQL pod and receiving a response confirms that our network policy is working as expected. Grab the IP address of the external weather service and note it down. You'll need it to add to the ipBlock.cidr field in our egress rule. Before updating the network policy, test the connection to observe the current behavior. You'll see that the request fails because of our existing net restriction, and that's our default deny policy. Let us modify our existing policy in the backend namespace and amend this rule to the appropriate section. The rule should have the explicit IP block, protocol, and port details. So let's apply this updated policy for the changes to take effect. So once applied, let's test the connection again from inside the MySQL pod, and we should now successfully receive a response from the weather API.